LTX 2.3 can now be used to edit videos. For this, we are going to use a special LoRA called Edit Anything. By using this LoRA, we can very easily add elements to an existing video or remove elements that are already in the video. Of course, we can also modify elements within the video. These are the three core operations in video editing: add, remove, and modify. Besides these, this LoRA also performs exceptionally well in changing the overall video style. However, when you actually use this LoRA, it might not be as effortless as I make it sound. There are a lot of details and potential pitfalls here. Among these three core operations, modifying is the easiest to pull off. Adding and removing have certain requirements. If the source material you choose isn't suitable, or if your prompt isn't accurate enough, it might lead to the failure of the add and remove operations. So how can we use Edit Anything to effectively edit an existing video? Next, we will break down the key points one by one. We can find this LoRA on Civitai. The training of this model used 8,000 pieces of training data, and it is currently still undergoing continuous training. So there will be new versions released continuously in the future. This LoRA is primarily trained for 4 prompt modes. These 4 modes are add, remove, replace, and transform. Using this LoRA in ComfyUI is relatively simple. First, the official page provides a sample workflow. Here we need to remind you guys that the workflow I am about to show you is slightly different from the one provided officially. Also, when using this LoRA, there is one thing you need to pay special attention to, and that is the CFG setting. Because we usually use distilled models or turbo models, we are used to setting our CFG value to 1. When using this LoRA, setting it to 1 is absolutely fine. But if you feel that your model cannot respond to your prompts well enough, you can consider setting the CFG value a bit higher. To make the demonstration easier, I have also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a fantastic online platform because whenever new technologies and new models drop, they always follow up immediately. Additionally, Running Hub provides an online community platform for ComfyUI creators. You can find tons of inspiration and sample workflows on here. All right, next we will break down the core components of the workflow in detail. You can actually think of this workflow as an LTX 2.3 first and last frame workflow. The only difference is that the frames we are referencing now aren't just the first and last frames, but an entire complete video. We have already covered the details of this workflow thoroughly when we talked about the first and last frames. So below, we will just quickly go over the key points. The workflow you are seeing right now is slightly different from the version we downloaded from the official source. First of all, the workflow you download from Civitai is basically a single pass sampling video generation workflow. It doesn't have an upscaling process. To make the video quality better, I added an upscaling feature. Furthermore, we also have some slight differences in the initial latent design, which we will mention to you guys later. Okay, let's first look at loading the main model. Here, the main models we are using are all provided by Kijai. But I need to remind you guys that Kijai is currently constantly updating his models. When you choose a model, try to pick the latest version. After loading the main model, we will connect and edit anything LoRA right after it. Since the overall purpose of the workflow is to edit a video, we must upload an original video, or what we call a reference video. What you are seeing right now is a video of a beauty dancing. I have some basic configuration items here, setting the resolution used by the workflow and the total number of frames. When loading the video, try your best to control its total frame count. After loading the reference video, we need to scale it. Note that we need to scale it down to exactly half of the target resolution. The reason is that after the first pass of sampling, we are going to upscale it by 2 times. Therefore, during the first sampling phase, we only need to generate half of the target resolution. After processing the reference video, next we will use the text encoder to do a basic encoding of our prompts to get the positive and negative conditions. I will explain how to write the prompts in more detail later. The prompt I am using here is very simple. It is to change the beauty's clothes into a red tight leather suit. Then we will use a node called LTXV conditioning, mainly to convert our positive and negative conditions once. Now comes the most critical point. For the LoRA to successfully edit the video, we will use a specific node. This node is called Add Guide Multi. We actually used this node when generating videos from first and last frames, At that time, we introduced two nodes to U. The other one was for direct replacement of first and last frames. But this one actually falls into the category of reference generation. Its inputs have the typical characteristics of reference generation, including positive condition, negative condition, and latent. The outputs are the newly generated positive condition, negative condition, and latent. Let's specifically talk about the latent here. In my workflow, this latent directly generates an empty one, but in the workflow provided by the official source, the latent is obtained by performing a VAE encode on the reference video. Since our sampling coefficient is 1, it actually doesn't matter how you set the initial latent. Additionally, we will connect the entire reference video to image 1. Pay attention, guys. The image here is not a single picture, but contains all the frames inside the entire video. After passing through this node, we will get the new positive condition, negative condition, and latent. Next up is the sampling process. This is largely identical to the sampling process provided by official ComfyUI. Note that we adopted a two-stage sampling strategy, the base video generation part and the upscaling part. There's one thing you guys need to pay attention to here. When upscaling, we must provide a reference first frame image. Under normal circumstances, we use the uploaded reference image for upscaling. However, in this workflow, since we are doing video modification, the video generated after the first sampling pass has changed quite a bit from our original reference image. We cannot use the original reference image as the basis for upscaling. Therefore, here we first do a VAE decode on the generated video, grab its first frame, and then use this first frame as the reference image for the upscaling workflow. This is where it differs from our traditional LTX 2.3 workflows. Next, let's take a look at the final generated result. We got a beauty dancing in a red leather suit. The consistency of the character with the original video is maintained pretty well. The video modification effect is also acceptable. Although we use the replace mode, the actual effect looks more like we just put a red leather jacket on the beauty. It basically fulfilled our editing intention. But no matter how you look at it, the overall editing effect is still very satisfying. What we just showed you was actually a replacement effect. We also mentioned when introducing this LoRA that it mainly has 4 prompt modes: add, remove, replace, and transform. Relatively speaking, replace is easier to pull off. Why? Because replace overall is about taking existing content in the video and swapping it for something else. The spatial footprint of the target object already exists. We just need to describe it as another thing. But the others require breaking the original pixel space distribution in the video, making them a bit harder to achieve. First, let's look at remove. Since remove is about making an existing object simply disappear, the overall difficulty of achieving it isn't too high either. The only thing we need to watch out for is that in your prompt, you must clearly describe the basic features of the object you want to remove. Let's look at the example below. In the video, there's a little boy wearing yellow clothes walking and chatting with a frog. The surrounding environment is a barren desert. Look guys, the two characters in the video have very prominent features, and they are very different from each other. So my prompt is written like this: remove the boy on the left. Let's look at the final generated result. You can clearly see that the boy has been removed, and it even looks like the model filled in the frog's shadow on the ground. The overall effect is stunning. However, we also notice some issues. For instance, there is a sudden appearance of an unidentified object here. So what exactly is this thing? By comparing it with the original video, we can see that it is actually one of the boy's hands. So why did this hand appear? If we observe closely, you will notice that at the very beginning, this hand didn't appear in the video. It was off camera the whole time. It wasn't until later, when the boy made a head-scratching motion, that this hand showed up. When we removed the boy, the model failed to correctly identify this hand, nor did it realize that this hand was also a target to be deleted. That is why this issue occurred. What you just saw was the most ideal scenario. In that case, each character in the video had clear features and was very easily recognized by the model. But if I swap the original video for the one below, there will be a lot of problems. Take a look. The two beauties in the video are also dancing, but the features of these two girls are quite similar. Although you might feel that their hairstyles or the colors of their clothes are somewhat different. For a video generation model, it still cannot accurately tell who is who. I used all sorts of methods in the prompt, but ultimately there was no way to accurately remove one of them. Therefore, to accurately remove an object in a video, the key lies in 2 points. One is that your prompt must be written accurately. The second is that the features of the character in the video must also be prominent and easily recognized by the model. Next, let's talk about add. I feel that add is the hardest among all the operations. The reason is that we have to add something that originally didn't exist into the original video. This in itself causes a massive shock and disruption to the original video's form, so it demands much more from both the video and the prompt. So how can we perfectly add an object into a video? Let's analyze the factors that might affect video generation. The first key factor is how much available pixel space is there when adding an object. This is very easily overlooked. Let me use an example to illustrate this problem. Take a look at this video. It shows a scene of a beauty taking an elevator. The video's clarity and the character's presentation are both incredibly beautiful. Next, we try to add a male character into the video. After processing it through the workflow, we will get the video below. Take a look, guys. Doesn't this video feel super creepy? It feels a bit like watching a horror movie. The male character did indeed appear, but from start to finish, we never see his face. He keeps hiding behind the girl and occasionally reaches out to gesture a couple of times. So why did this happen? The reason is because we didn't have much available pixel space. In the entire video, the beauty takes up most of the pixel space. If you want to add a person into a video like this, it will be relatively difficult. Besides the factor we just mentioned, there is another factor that affects our final video editing, the intensity of camera movement. Let's look at the video below. This video shows a beauty dancing under a cherry blossom tree. Pay attention. This video is horizontal. The beauty, as the main subject of the video, doesn't take up too many pixels, so there isn't an issue with insufficient pixel space, like we just talked about. If we try to add a male character into the video right now, we will get the following result. At first, it is indeed a man and a woman dancing, but after the camera flashes by, the beauty runs away, and only the male character is left. To get a better result, I also tried different prompts. For instance, emphasizing that a man and a woman are dancing together, or emphasizing that the man is next to the woman, but the final results were none too great. After extensive testing, my final analysis is that the reason is the camera movement is too violent, even creating a camera cut effect. If the camera is relatively stable and uses a continuous single take, our editing effect will be much more obvious. For example, let's look at the example below. This example shows a man sitting on a bench reading a book. First, we have enough pixel space to add a person. Secondly, the overall camera movement is quite smooth. Now, we try to add a female character next to the man. You will find that there is absolutely no obstacle here, and the overall feel is fantastic. Finally, let's look at transform. Transform here actually means style transfer. This is actually the easiest to achieve because it is about changing the style of the entire video. If you find that your style transfer isn't strong enough, it is either because your target style isn't prominent enough, or it is possible that you set your CFG value too low. You can bump it up to 1.2. Here, I used an original video of a beauty making funny faces. My prompt is to transform it into the Makoto Shinkai style, which means an anime character. After we perform the transformation, you will see that this style transfer is extremely obvious. I also tried various other styles, like Ghibli. But to be honest, I feel like those two transformations look pretty much the same. So I think the model might still need improvement in terms of the level of detail when presenting different styles. The LoRA we introduced today is extremely interesting. From a technical detail perspective, it belongs to reference generation, but it does indeed achieve local inpainting or video editing effects. Although the commands we can currently edit are relatively few, mainly just 4, the overall performance is still quite good. The model is also constantly iterating and optimizing. I believe future versions will bring us even more stunning effects. Alright, that is all for today. What are you waiting for? Go try it out yourselves. Follow me to become someone who truly understands AI.